This is your brain on drugs. No, really, just maybe not the kind you're thinking of. Every day, there are many reasons lots of people have to take medication for their brain, and today I want to explore how exactly those work.
The brain is an organ made up of many different cells, but mostly neurons. These neurons use chemical transmitters and electrical impulses to pass signals between each other. And that's all well and good, but what happens when something goes wrong? We all know that many medications for the brain exist, but when simplified, there's only 6 general ways medication impacts the brain. First is agonist and antagonist. All that means is that the medicine enters the brain pretends to be something else by binding to the same receptor. Agonists aim to produce the same function, and antagonists aim to prevent the function. For instance, I take a medicine called cabergoline, which is a dopamine agonist. I have a benign tumor called a prolactinoma on my pituitary gland, and to make it go away, cabergoline binds to dopamine receptors to inhibit a hormone called prolactin. The pituitary gland isn't even part of the brain? That was the whole point of me getting into this in the first place. And we have reuptake inhibitors. These medications prevent a cell from taking back a substance that is released to make the effect last longer and enhance it. An example of this is the medicine Prozac, which blocks the reuptake of serotonin in the brain to help improve mood and reduce depression and anxiety. Third, we have medications that work on enzymes to either inhibit or promote their function, like acetaminophen, which stops a headache by inhibiting COX enzymes, which make a substance called prostaglandin that your nerves can pick up and deliver to your brain as a pain signal. Fourth, we have medications that can either impact how easily a neuron can receive a signal or can promote the growth of new neurons. Wait, you can grow new neurons? Well, what do you know? And it can be promoted by medications such as memantine, which can be used to treat Alzheimer's. Fifth has to do with the blood-brain barrier, which protects the brain. Some medications can be used to make it easier to get through, and they are often used along with another. For instance, mannitol is a medication that makes it easier for doxorubicin to get into the brain, where doxorubicin helps to fix things like brain tumors. Finally, we have medications that change how DNA is read. Imagine DNA as a giant instruction manual that every cell in your body reads to do its job. What medications such as Spinraza can do is temporarily black out parts of the book so the cell can't read it to stop the production of things like dysfunctional proteins. And that's all. I hope this helped you gain a better understanding of how the medications you take impact your brain. After all, the brain is one of the most important organs of the body, but sometimes it needs a little bit of help, which is why medicating the brain is truly an art that needs to be appreciated.